Hello, chemists. Jolly again. Let's continue on with the electrolytes. We go to the whiteboard, and we are going to talk about how to write electrolyte equations. And remember, there's two types of electrolytes. There's ionic and there's molecular. Ionic equations have to be written as a dissociation. Dissociation. And molecular means we have to write them as ionization. Now, that's a fancy way of saying dissociation means basically dissolved, which means it started ionic, then dissolved in water. Now, moleculars, on the other hand, means that it started molecular and it reacted with water to make ions, hence the term ionization. Now, that doesn't seem like a big deal, but it's very important to know where the pieces came from. And so we need to always be able to write one of those two equations. I'm just going to erase this and start with a fresh one. All right, so let's start with the dissociation. All right, the first thing you do is always start with an ionic solid. Well, how come I can't start with an ionic something else? Well, all the ionics come in solid form. All right, so I don't care which one it is. Sodium chloride. Dissociation means to dissolve in water. So I'm going to put H2O right there. You can put L or AQ. Now, there is no reaction. It literally is just sodium ions, now floating around in water, plus chloride ions floating around in water. There is no reaction. It literally is being dissolved. So this is also okay to write. I'm going to put the water above the reaction arrow just to show that it's the solvent that's doing the dissolving. Right, and that's it for dissociation. It doesn't matter what ionic solid you start with, you just break it up into its parts. Now, what if it's not one-to-one? So for instance, magnesium chloride. You would take it to all of its parts. So it would break up into two chloride ions. That's the way you would do dissociation. Now, ionization, on the other hand, is a reaction. Which means water is not just dissolving, water is actually doing something. So this is going to explain why I told you you always had to have AQ behind binary acids. So for instance, HCl comes as a gas. If you put that in the presence of water, it does not dissolve, it literally reacts. Let me mute you for a second. Just to make it a little clearer, I'm going to draw some arrows for you. So those are the electrons on the water. The oxygen will literally attach itself to the hydrogen. Well, hydrogen can only have an octet of 2, so it will donate those electrons to chlorine. So what I've made is actually something called the hydronium, which means water plus a special extra thing called a proton. Okay, so that thing is called a hydronium ion. Basically, it can be written as a shortcut as just a hydrogen with a positive charge because it's just a proton because it's lost its electron. Ha ha ha. All right, that's what acid means when we are using them. That's why it has to be written on the left. Ionizable means it has to be able to react. It has to be able to be ripped off. So ionization reactions, it did not start ionic, but it ended with ions. And if it ends with ions, it can conduct electricity. All right. When are you going to use your ionization reactions? Anytime it is molecular. Oops. All right, that would. All right. So you are going to use it for acids and ammonia. So let's take a look at what ammonia is doing. Ammonia occurs in nature as a gas, and it will also react with water. I'm writing it a little bit different this time because the nitrogen in this case is going to be the one that attacks the hydrogen, going to give up those electrons, and we're going to make, oh, we recognize this thing, or another way to write it. If you take ammonia gas and you put it in water, it will react and it will make the ammonium cation and it will also make the hydroxide. But again, there's ions over here where there were no ions to start with. So this is an ionization reaction. All right, that's the difference between the two types. Now let's do another acid. Let's do HClO4. So the same thing is going to happen. We are going to make H3O plus ClO4 minus. Again, this is an ionization, but I'm going to show you a shortcut. Never use a shortcut unless you understand why it works. We are going to leave the water out only because we always know it's there. So this is okay for the ionization equation. H plus does not exist. It is a shortcut for H3O plus, but it is understood that if you don't want to keep writing water over and over, that it just shortens things. It makes it speed up. So you're more than welcome to do that. All right, what about protic means it has an ionizable hydrogen. Monoprotic means it only has one. Polyprotic means it has many. And I guess we get specific, diprotic means it has two. So for instance, H2S exists as a gas. If I react that with water, and I hope you notice, I'm very clear. I react with water versus I dissolve in water. But there's two hydrogens, so water can pull them off, but not necessarily at the same time. So the first thing that's going to happen is one of them is going to get pulled off, and it's going to make H3O plus, and I could have used a shortcut, but then guess what? That will react with another water to make S2 minus. All right, just because it has more than one is fine, but you still just take one off at a time. All right, so that's the difference between dissociation and ionization. Why do we use those? Dissociation. Hmm. It shows how the electrolytes are reacting and or getting dissolved in the water. That is their whole purpose. Okay, well, what are we going to do with those? Right now, nothing. So that is literally all I'm going to talk about here. It's just, can you come up with the dissociation or ionization equation? So number one, we're going to go back to that handout, which is right here. Every time you answer one of these questions, you should be able to write out an equation for it. You'll know whether to write out a dissociation or an ionization because all ionics are written as dissociations and all moleculars are written as ionizations or nothing. Remember, we're just talking about electrolyte right now. Can moleculars dissolve in water? Yes, they can, but those aren't the ones that I'm interested in right now. So after you get through doing this portion, try and do a few of those so that you can get familiar with dissociation and ionization. And let me see, I have that somewhere. Right here, question number 5. Determine and write out the dissociation or ionization reaction for each of the reactants in question number 4. All right, so again, a good practice. It's not on the answer key, but you should be able to write one of those equations for every one of these. All right, until next time, jolly up.